Good morning. So today,
Morning, sir.
yeah, good morning.
Good morning, sir.
Yes. So today we are going to start, though we have already discussed the basics of principles of remote sensing and general application in the previous lectures. But few new students have joined this course. So again, all those concepts and discussion I'm going to repeat. Okay. So this is one of the course which you are going to do in this semester out of 5 courses, and the course structure of this course include the content in unit 5, and the contents are in unit first. You will be learn about the electromagnetic radiation and its properties. Okay. So as we know that for the remote sensing or acquisition of different information, we require the energy source. Okay. And most of the remote sensing tools use sun as an external energy source. So that is a reason why you need to understand the electromagnetic radiation coming from the sun, and further the energy sources and radiation principles. It means how that energy is generated from that source. That will be discussed in our radiation principles. Then once that energy interact, if let's say sun is considered as an external energy source, so light coming from the sun, it passes through the medium, that is a atmosphere around the earth. Okay. How that energy interact with the atmosphere, that we will discuss in detail. Okay. Then further that energy reaches to the earth surface. Okay. And how interact with the different earth surface features, and what are the response of earth surface objects. Okay. Now in the second unit, we will discuss about the remote sensing platforms which carry the sensors which collect the information. Okay. Then in unit third, there will be discussion on thermal, hyperspectral, and microwave remote sensing techniques. In unit 4, we will discuss about this processing of the images, specifically the images which are acquired by these remote sensing tools. Okay. And then last unit, we will discuss about the one of the advanced remote sensing technique, that is LiDAR. It stands for light detection and ranging. And we will discuss about the general concept of GNSS, Global Navigation Satellite System. And further different case studies we will discuss in terms of application of remote sensing. Okay. So very quickly, the content I discussed over here to a particular workflow. Again, I'm going to brief these things. So let me share another document. Okay, this particular diagram covers the content which we will discuss in the complete syllabus. Okay. So as you see over here, there is a depiction, the step A, that is sources of energy. Okay. So there could be different sources of energy. It could be the internally connected with the imaging system or sensor. Okay. So in very general term, if I use a term sensor over here, so you can consider like camera. Okay, all of us are familiar with camera. By using camera, we click the images, okay, and we get a photograph. So consider that camera could be a active remote sensing tool if it has its own energy source, like if you use the flash. Okay, so by using the flash, you don't need the external energy source like sunlight over here, and even you can collect the images in night. So if that flash is an internal energy source that is inbuilt with the camera, so in this way it is categorized as a active remote sensing technique. Okay, now the source of energy could be externally located. So we consider sun as an external energy source for most of the remote sensing techniques. Okay, so sun generate its own energy and it radiates towards a 360-degree solid angle. Okay, so that's why a sun is considered over here as an external energy source. Now that energy propagate outward from the sun surface area, and it also enters into the earth atmosphere. Okay, so there is a propagation through the atmosphere. Okay, so once that energy enters the earth atmosphere, there is a certain interaction in terms of losses of energy. Okay, so there is a atmospheric particles which interact with the energy and decrease the amplitude of energy at a different wavelength. Okay, so further that energy reaches to the earth surface and it interact with the earth surface object. Okay, so after interacting the earth surface object, part of energy reflected back. Okay, and some part of energy is absorbed and remaining energy is transmitted. So that reflected energy is again passes through that same atmosphere, and further it is sensed by the, just see the type of platform which we have over here. So these are the sensing system. It is listed in E. Okay, in section E they are listed. So it could be satellite based, it could be airborne, okay, or it could be terrestrial. If you are operating a tripod based camera in the daytime, and if you are not using the flash, okay, so that camera photograph depends on the light coming from the sun. Okay, on all the features or objects which image is acquired. Okay, so based on the plate we need to discuss about these platforms. Okay, and what is a mechanism through which the images are acquired. Okay, if let's say if we install the imaging system on the airborne platform, then once that airplane fly, what is a mechanism through which the images uh, of the earth surface objects that is seen by the sensor is acquired. Similarly, the satellite based platform and the integrated sensing system, how they operate, how they rotate around the earth, it will be discussed. Okay, then after that the sensing products, using the imaging system we collect the information. Okay, that information is stored. Okay, so they are the sensing product. How that product can be used for the various remote sensing based applications. Okay, so further those data which are captured through this process, they are interpreted and analyzed. Okay, so the interpretation and analysis is done by the remote sensing analyst. Okay, once you, and it's a office work. Once you get the images, how you can process the images, how you can analyze the images. So this interpretation and analysis part will be the laboratory experiment. We'll discuss about the theory behind this, and to have a kind of laboratory experience on this, there will be a few experiments and which you will conduct in the laboratory. Okay. Then after that, information product. What kind of information product you generate that is related to the application, and the last step is the end users who are going to use that information product for their applications. Okay. So again, I'm going back to the PPT. So I hope, and there are certain reference books, even two additional books also I have uploaded. So the first book which we are going to refer is Remote Sensing and Image Interpretation by Lillesand and Kiefer. Okay. And in addition with this, two additional books I have already uploaded in this Teams. So you can have access of those books, and these two books also you can refer. Okay. So before discussing the unit 1, we will have discussion on some background for the geoinformatics. Okay. So it's a very obvious query what we do in the remote sensing. Can anyone tell me? It's a general question. What we do in remote sensing and how it is done? Whatever you know, you can discuss with me, or you can discuss with the class. Yeah, Parul, you want to
Yes,
speak?
sir. Yes, sir. Sir, in remote sensing, we detect or monitor the physical characteristic of the Earth's surface by reflection and emission or radiation of the object from the object.
Okay, correct. See what we do in just see the name remote sensing. Sensing means somehow you want to capture the information of certain entity. Okay, it is meaning of sensing, and that information acquisition of that entity is remote. It's a remotely access of that information. It means without touching that object, that entity, you want to collect the information. Okay. So this is a general meaning of remote sensing. Okay. What we do in remote sensing, if you see your branch name is Geo-Informatics. The same field. So the Geo-Informatics is related to the Earth surface in
सर वॉइस नहीं आ रही है। हेलो सर। I don't know what's wrong here.
Okay, so I discussed about what do we mean by geoinformatics. Okay, so it is a information acquisition of Earth surface objects. Okay, and further processing. Okay, and so how do we measure the geoinformation and what do we mean by geoinformation over here? Okay, so let's say we start analyzing from our perspective. Okay, so when we see the object, how we sense it, okay, and how we process it, and what kind of information we collect. So if you see that when we analyze the objects by our eyes, okay, so we categorize and differentiate the objects on the basis of their color, their shape and sizes. So overall, by analyzing the dimension of the object as well as their color, we differentiate them. Okay, so the two category of information that we sense are they are geometric and radiometric. Okay, in the geometric information, what we have the entire dimension of the object in terms of its shape and size. while in the radiometric information we have the color of the object, or we have the pixels that related to that particular object, okay, which are further seen in the form of unique color. So radiometric information, it contain a set of numbers which we call digital numbers, okay, and those digital numbers contain the information of the object in terms of what amount of energy is reflected back from the object. So briefly, if you see in this figure, so this particular area is sensed by the satellite-based imaging system. It's a camera there, okay. And once, as I discussed before, from the sun, electromagnetic radiation reaches to this surface objects, then there is a reflected energy. So radiometric information, it means it is related to the radiometry. Okay. So once that energy interact with the object, how much amount of that energy is reflected back? And further, that reflected energy or radiated energy is sensed by the sensor. Okay. And a unique number is assigned for that. We'll have a detailed discussion on this later on. So that is called as a radiometric information. And when you see over here, this 8x8 graded data is shown, this 4x4 graded data is shown over here, and each square block is filled with a number that is called a digital number. Okay.
Sir.
And yeah.
Sorry for interruption, sir. Visual are not coming, sir. Slide on screen.
Is it the case for all of you?
No, sir.
No.
It's coming.
No, sir.
No, sir.
So can you see the PPT at
Okay,
your
sir.
end?
I will.
Okay. Could you please you can just check out the bandwidth available with your internet connection. There might be some low bandwidth issue.
Okay, sir. I will rejoin it, sir.
Yeah, you can do it. You can rejoin it.
Yes. Okay, sir.
Fine. Let us wait for let's say 1 minute so that he can join. So okay. So if you see over here, so a particular area from the ground, from that area, the energy which is coming out, that energy is sensed, and one number is assigned for that. Okay. And further, when you display this image on your screen, you can see the different sets of color. If it's a grayscale image you are assigning, then you can see the different sets of gray color. Okay. You can do this experiment, like all of you have photograph with you, and just try to zoom in the photograph. You can see after certain level, what will happen, your image will be pixelated. You can see the square block with the specific color. Okay, so, and each block is painted with a unique color. So in background of that color, there is a number. Okay, and that number, there is a energy which is coming from that ground cell. Okay, so this is the backward workflow. So there is a backward flow on your mobile phone or on your screen. When you see the photograph, just zoom in, and at a certain level till you can't see the pixelated image. Once you see the pixelated image, you see a unique color is used to paint the complete square block, as you see over here in this diagram. Okay, just behind that square block, okay, on your computer screen, the color can't be stored. Okay, on your disk there is a storage of the decimal numbers. So these digital numbers are stored in its decimal version. Okay, and sorry, it's a binary version. Uh, these digital numbers, their binary equivalent is stored on your computer disk. Okay, and further, that digital number is representation of magnitude of energy that is coming from the actual ground cell. So there is a small square block on the ground. Okay, so the actual information that is reflected back from that square block is finally represented, is given a certain number based on the energy magnitude. Okay, that's why it is called as radiometric information. It is related to the energy analysis and further conversion of energy magnitude into a specific number, then final allocation, final assigning a distinct color to that number. Okay, and the same thing our eyes do when we see the object from the, let's say, in the daytime, if we are looking at an object, already the reflected energy is there from that object. That reflected energy is sensed by our eyes. Okay, and then based on the magnitude of energy that is there in the reflected energy, that magnitude is analyzed, and finally a specific color we can see from that object. This is one part. And another part is a geometrical understanding, geometrical analysis of the object. So we have a capability to sense the object in 3D. Okay, so we can have a feeling of depth of the object, height of the object. So in three-dimensional Euclidean space, okay, we can see the length, width, and depth both. So when we have the capability to sense the 3D, the three-dimensional detail of the object. So on that basis also we can able to distinguish the various objects. Like let's say if there is a query, if you see two houses, so can you able to distinguish the floor area of this roof area of two houses? You can do it because you have the capability to sense the dimension of the object. The same analysis we can implement using the artificial remote sensing techniques. What we do, the same analysis is incorporated using the artificial sensing system. Okay, so work of our eyes and our brain, it is implemented by using the artificial remote sensing tools and further processing of that data using the computer. Okay. Like in this slide, if you see that, then the ground area that is imagined, so that is sensed or imagined by the remote sensing system. Then further the data set is generated in terms of different set of digital numbers. Okay, those digital numbers are stored. Then after that, like our brain process to analyze and interpret the information which are perceived by our eyes, the same task can be artificially done by the computer. So now that computer, by the help of remote sensing analyst, So we can provide the instruction to the computer to process the image for the information which we want. Fine. So is there any query? Just I would like to cover over here overview how on the basis of our daily routine, what we do, okay, how we can correlate with the concepts which we are going to cover in this course. Okay. So if is there any specific query?
हेलो सर।
Yeah, Arun, please tell me.
सर जैसे कि जो फाइनल आउटकम आता है किसी भी मैप के द्वारा जो हम लोग देखते हैं, चाहे इंडिया का हो चाहे किसी का हो, तो सर जो कलर्स होते हैं ये उसी को रिप्रेजेंट कर रहे हैं नंबर, ऐसा कुछ?
हाँ, वो जो listen, जो the color which we see, though it is a part of second unit, how we assign color to the images. Okay, so this color assignment is the last stage in the it's a analysis stage. Once we collect the data, okay, when we are going to analyze that data, then what we do, we open that data on the screen, okay, and we can see the color. So the color assignment is done for the analysis only. And if you see that in the background of that color, there is a digital number and its equivalent binary number is stored on the disk. So color is not stored on the disk. It's not a data product. Color is not a data product. Okay. Data product is only the binary equivalent of digital number along with the location information from where that pixel is collected. Okay, that is there as a data product, and when you open it on your screen, let's say if you are going to open it on your laptop, okay, so once you click it, when it is open in a window, so there is a provision in the laptop to assign the color. Okay.
Yes, sir.
So corresponding to each digital number, you can see the unique color. So the concept of color cubes, how we can mix the three primary colors, we'll discuss in detail later on.
सर मुझे एक चीज़ और पूछना है
हाँ,
कि जो एनर्जी होता है पैसिव एक्टिव दोनों जो भी हैं सर, तो सर वो जो रिफ्लेक्ट होके जो ग्राउंड से निकलते हैं, तो सर जो उसका पर्पज है सिर्फ इमेज को कैप्चर करने के लिए होता है, जैसे आपने कैमरे का एग्जांपल दिया कि जो उसकी फ्लैश लाइट है वो उसकी खुद की सोर्स है जिससे कि हम रिफ्लेक्ट होके इमेज को कैप्चर करते हैं। तो सर जैसे कि जो सन से लाइट पड़ती होगी अर्थ पे, चाहे वो रिवर पड़े चाहे फॉरेस्ट पड़े, तो सर जो हम इमेज कैप्चर करते हैं उसी को हम ओवरऑल रिमोट सेंसिंग बोल सकते हैं क्या, ऐसा कुछ?
हाँ, that is a remote sensing. See, the meaning of remote sensing without touching the object physically, collecting the information from the object. Do you know its meaning is simply remote. Remotely acquisition of object, remotely sensing of the object information is called as remote sensing.
Thank you, sir.
Okay. Okay, so one important point which we have been discussing continuously, that is energy coming from the external energy source or internal energy source. Okay, so that part again you need to understand, and that is first content of unit 1, that is electromagnetic radiation and its analysis. Okay. So before going to discuss a few more basic contents, I would like to cover that part before, and let me share another document.
Sir,
Yeah, Alok, batao.
sir, in this slide, sir, few minutes the visual was lost, so I missed that part. Sir, what is the number written 1 to 5, 10? 125 10 in piece square.
See, by using a remote sensing system, consider, for example, camera. Okay. So by using the camera, when click the image, okay, and when you visualize the image on your computer screen or on your mobile phone, so just start zooming it. At certain level, you can see the pixelated image. The meaning of pixelated image is you can see the square blocks painted with different colors. Okay. So that color is actually assigned to a digital number. Okay. And that digital number is further representation of amount of energy reflected back. Like these numbers, when we talk about these numbers, so these numbers are containing the magnitude of energy that is reflected back from the gridded ground surface from where that image is acquired.
Why, sir?
Again, let me clarify it in more simpler way. Just hold your mobile phone, okay, and target it at some object. What does that sensor, which is inbuilt with your camera in the mobile phone, what that sensor does first? That sensor automatically divide the total area which is in the field of view of the sensor into a square blocks. Fine. Let's say if your camera focus is in the area, let's say 3 meter by 3 meter. Okay. So that camera sensor, okay, divide that 3 meter by 3 meter area into square blocks, or that gridded that area where each grid represent a square block. Let's say if it is gridded into 2 centimeter by 2 centimeters, that block. So 3 meter by 3 meter area is virtually divided by the sensor into a square block of connected square block of size 3 centimeter by 3 centimeter. Is it clear?
Yes, sir.
Okay. Now what happens? Now you need to expose that area which is in the field of view of your camera by some energy source. Okay, that energy source could be, if it is night, then you need to use a flash. Obviously, you don't have a light. But if it's daytime, then automatically you have the sunlight. Okay. So from the energy source, the energy is radiated towards that area which is in the field of view of your camera. Okay. Then further what happens? That area starts after the interaction of the energy which is coming from the external source. Those 1 centimeter by 1 centimeter square block. Okay. From that each such blocks, the energy is radiated or reflected back. Okay. Now
Yes.
I am considering only one block, a square block of size 2 centimeter. Okay. So the energy is reflected back, and there is a charge couple. There is a sensing device in your camera sensor. That sensing device senses the amplitude of the energy which is coming from the 2 centimeter square block. Okay. Similarly, there are large number of square blocks in area 3 in the gridded area 3 meter by 3 meter. For all those square blocks, a distinct energy is sensed by the sensing device. So you have a set of analog energy signals which is already sensed by the sensing device. So for each square block, you have a you have a magnitude of energy. Then what happens? Those energy components are vary from one minimum component to maximum component. Then further, what it is done at the sensor end, once that energy is captured, set of energy components are captured, they are divided into the uniform segment that we call analog to digital conversion. So those, like let's say if you have a number, let's say if there is a 0 to 100, not 0, minimum could be 0 and maximum is 100. These are the energy component from all the cells. Okay, so there might be possible most of the cells have energy within 5 to 10. Some cells have energy magnitude within 80 to 70. Okay, but we do not analyze in that way. What we do, we divide it into the equal segment, let's say by unit 10. So 0 to 100, we divide it into 0 to 10 one segment, 10 to 20 another segment, 20 to 30 like. So we have a 10 unique segments. Similarly, though our computer system stores the information in binary format, so better to consider the binary numbers type of binary sequence we have for such kind of segmentation. Let's say 4-bit can be considered, 8-bit can be considered. Let's say if we consider 8-bit over here, because the number which are given in this slide, they vary from 10 to 125. 7-bit is sufficient. But let's say if we are considering the 8-bit, 8-bit means, I hope all of you know that in 8-bit we have a 256 distinct sequence of binary numbers. Is there any doubt in that? Again, there will be discussion on that, but I'm connecting. Yes, Arun, you want to say
yes
something?
सर बिट वाला कॉन्सेप्ट मुझे पता नहीं, बट ब्रीफली अगर आप थोड़ा सा बता दें तो कुछ आइडिया हो जाएगा.
Fine. Right now, I'm not going to discuss that part. It will be discussed later on. So I'm just leaving the bit part over here. Let's say, as I discussed before, the magnitude of energy, that magnitude of energy is lying between 0 to 100. But for the storage of that magnitude, again, the each 3 meter by 3 meter square block that is gridded into 3 meter by 3 meter is a total area that is in the field of view of your mobile phone camera. Okay, that is gridded, and size of each grid is 2 centimeter by 2 centimeter. Each grid energy coming from each grid is sensed by the camera. Okay, and further those energy magnitude are recorded. Fine. If let's say those minimum and maximum of energy magnitude lies between 0 to 100, so for the representation on the computer disk, you are not going to store the magnitude information of the energy. Rather, you divide it into the equal segment, and the energy magnitude which are falling in a particular segment, all those energy magnitude are represented by same number. Okay, let's say 0 is minimum magnitude and 100 is maximum magnitude. So 0 to 10 one segment, 10 to 20 like that. So similarly, you have a 10 segments. Okay, so all the energy component which are lying between 0 to 10, they are given a unique number. Then 10 to 12, they are given another number, 10 to 20. So you are providing the 10 distinct number to the energy component, and those numbers binary equivalent is stored on the disk. This is a simpler way through which this concept can be discussed. Now, that binary sequence corresponding to, do you know, this is the reason why, if you see in the figure, most of the cells have a same set of grayscale. Okay, The same set of grayscale means they are having the same number. Is it possible? There might be slight difference between the energy coming from that object. Okay, but the slight difference, if they are lying within one segment, let's say 0 to 10. So let's say if you have 5 cells, and energy coming from those 5 cells are 1, 2, 3, and 4 and 5. But though they are in same band 0 to 10, they will be given only same number, and that binary equivalent of that number is stored. And once you are going to open that image, for each digital number, a unique set of gray color is assigned, and that particular color you see on your screen. I hope now it is clear. Okay, so moving ahead in this discussion, what do we actually mean by geoinformation from the Earth surface perspective? So any artificial natural object like trees, buildings, etc., and any phenomena like flood on the surface of Earth or below the surface of Earth are called as geoinformation. Okay, and that geoinformation is sensed in terms of their geometric information and their radiometric information. So there are certain list of geoinformation which are written over here, and you can see in the diagram as well. So like land related information, so different land parcels which we can see in the urban colonies. Then road network. Road network is a kind of an artificial object. Then topography of the surface, forest cover, they are the natural object. Then houses, river, flooding is a kind of phenomena. Okay, glaciers. So all these are the geoinformation, and it is recorded. The details of the geoinformation is recorded using remote sensing techniques, and they are recorded in terms of their geometrical detail and their radiometric detail. So if I consider over here, what do you mean by geometrical detail? So that geometrical detail retains the location of the object, it retains shape and size of the object. Okay, from where that object is and what is the shape and size of that object. And radiometric information retain the color of the object. Okay, so there are two fundamental division of geoinformatics. The first one is how do we measure the geoinformation, and the second one is how we manage it. Okay, so in a general discussion, if we see the measurement of geoinformation, so we do the measurement of geometry, time, and we identify it, what it is. Okay, let's say if there is a application to measure the distance between two houses. Okay, so what you do, you select a two reference point on each house. Okay, and you measure the length. So that length gives you idea about the distance between two houses. Okay, so that length measurement could be done either using tape. It's a traditional way to do it, or you can use it chain. But nowadays we have a advanced tool, that is electronic distance measurement instrument. So EDMI, just you need to put it at the reference point on one house and just focus the reference point on the another house and just switch it on. So there is a laser beam. That laser beam travels in a straight line that hit the the second point, and that distance is automatically given by the PDMI. Okay. So now here we have the categorization, the traditional methods to do the measurement and advanced tools to do the measurement. Okay. So the limitation of traditional methods, which are very time consuming, they are labor intensive. Okay. That problems have been solved now, and we have the advanced tool by using which very quickly we can collect the geo information. Okay. So let's say the example I discussed with you, the distance between two houses. So to in this measurement, what do we mean by geometry? Let's see. So the geometry means if we want to analyze it from the mathematical perspective, okay. So how we can measure the distance between 2 points? So first of all, we need to define a coordinate system. Okay, who is going to tell me? From the perspective of three-dimensional coordinate geometry, how we can measure the distance between 2 points? What are the requirements for that?
Sir, angle required to measure something.
Sumit,
Sir, angle and three coordinates.
see, I am talking about a three-dimensional coordinate system where we are in three-dimensional geometry.
Yes, sir.
In 3D geometry, by considering the
Yes.
three-dimensional coordinate system, our aim is to measure the distance between 2 points. What
Distance.
should be
We
the
only
understanding?
require the
Sir,
only requirement
we need distance between 2 points in three-dimensional geometry.
No, that is fine. What I'm asking, what should be the basic understanding which you will you have?
Sir, about what exactly?
How to measure the distance between 2 points? What are the requirements, and what should be the basic understanding? Let's say if you are going to design that entire process by writing the
Yes.
script, by writing the algorithm, or by for developing a particular equipment, what should be the understanding for measurement of distance between 2 points in a 3D space?
So first we should decide an origin from where we should take the reference, and with that reference we can choose particular
Yes,
coordinates.
correct. Just I would like to discuss along with you. Just you tell me like what concept you have. Then further I will elaborate that. So Sumit is telling like first you need to fix the origin. It means first you need to select the coordinate system. Okay. So the coordinate system, how we select a coordinate system and how we define it. So to define a coordinate system, first we need to fix the location of origin, and we define the three axes x, y, and z. What are their direction? Okay. Let's say if you consider again the same example I take, the distance between two buildings. Okay. So select one building as a reference point. One corner you select it. One corner of that building is chosen as that is connected to the ground, that you can select as a origin. Okay. Now the vertical that vertical corner which is going upward, that facade. So vertical facade direction can be considered as a z-axis, and similarly the this x and y coordinates are defined, okay, with reference to one corner of the building. So you have already decided origin and direction of three axes, okay, and their orientation, whether they are right-handed system or follow a left-handed system. Yes. Okay, Sumit, continue further.
So after deciding the coordinates, we can have two options. Either we have two coordinate points and one angle, or we can have three coordinate points only. So with the help of two coordinate point and one angle, we can locate a point directly by first by locating a point by coordinates, then choosing the angle which we have given. And one another thing is like if we have all the three coordinates, then we can locate a point.
Okay. Correct. So what we do next? Now we need to measure the reference point on each building in that coordinate system. Okay. So there are two ways. Either you follow the Cartesian coordinate concept of this in Cartesian system, measurement of point coordinate. Okay. So if you are following the Cartesian system to measure the point coordinate, then you need to measure what is the XYZ value of that reference point of building 1 in that coordinate system. Similarly, you need to measure the x2, y2, z2, that is a reference point on building B2 in the same coordinate system. So in the same coordinate system, the reference point on building 1 and reference point on the building 2, that their coordinates are measured, okay, and their coordinates are measured in XYZ format. And after that, you can take the square root of x2 minus x1 square, y2 minus y1 square, plus z2 minus z1 square. And you will get a 3D distance. You will get a 3D distance between the two reference point. Okay. But actually, you want to calculate the distance between those 2 points, then only you need to consider the x and y value. Fine. Okay. So how we can do it? This we have discussed from the aspect of three-dimensional geometry, coordinate geometry. How we can implement it using the remote sensing technique? Okay. So we will have discussion on this. So there are the tools which can able to compute the coordinate. Okay. And by picking those two reference point, which are labeled, which label each building, you can be able to measure the distance. Okay. Now, what are the traditional way which we have? The traditional way which we have for the same thing is just using chain and tape and physically measure the distance. But let's say that there are many obstruction in middle of those two buildings. It's difficult to measure it. Okay. So that's why the remote sensing techniques comes into the picture over here. So there are many limitations in a traditional way to do it. So therefore we adopt. So the measurement of geo-information, geometry measurement we do. At the same time, we do the measurement of time, at which time that measurement is performed. Okay. So what is where? So in this particular case study, there are two buildings. Okay. They are identified. There are two buildings, and further the geometrical analysis between those two buildings. So the second aspect, where they are, So when you have a coordinate of a reference point from each building, those 3D coordinates tell you information about where those buildings are in that coordinate system. So you have defined a local coordinate system over there. Okay. In that local coordinate system, you have a reference point coordinate of one building and a reference point coordinate from the second building. So those two reference points locate the buildings. Okay. Now identification. So the 2 points which are there, those 2 points belong to the building, 2 buildings. So this is their identification information. What is what? So they are the building. They are located at this point. Okay. And let's say further, if we come to the application, there is some online order from one particular building, someone from that house. Okay. So the delivery boy which want to deliver that item over there, so on the basis of location information of that building, that delivery boy can put that location in the this application which he has. Okay. And that application guide him to that building. Okay. And he can go there and he can deliver the item. Okay. And similarly, the delivery time can be recorded over there. So just see, there are a lot of information, okay, which are associated with one particular task. Okay. So there are multiple tasks over here. Just see. In this case study, we have discussed about the 2 buildings and their location in a coordinate system. Okay. And how that information is used for the delivery purposes, in terms of if that in online shopping, if someone from a building placed an order. Okay. So how a courier boy can deliver that item, how then courier boy can identify that house. So there is a way using an tracking application in the device. He can put the location which is already given there, which is already computed earlier. Okay. And that application guide him to that house. Okay. And he can deliver that particular product. Okay. And that time of delivery, etc., that can be recorded. Okay. So now you see the GIS database which is there in the entire delivery process. Just see that entire GIS database requires lot of logistic, lot of geo information to execute that. Okay. There is a requirement of just complete map of the city. Okay. There is requirement of location information of house. Okay. There is a requirement of this for the tracking. There is a requirement of GPS signals. Okay. So the measurement of geo information, just as I discussed before. So these geo information measurement are required for the applications to execute. Okay. And the geo information, it is identification of the objects, from where they are. Okay. What are the other details? What are the shape and size of the object? Okay. How we can identify them? I hope it is clear. Sunil Kumar, could you please unmute? Sunil, I'm asking you, could you please unmute? Yeah, Bhagat, I think you were saying something.
No, just I was
described the same problem regarding the
Okay, I
two
think
coordinate.
that is clear now.
Yes, sir.
Okay, fine. Any one of you, if you have a particular query, you can share with me. We can have discussion on that. Okay. So further, this is one of the case study related to the geoinformation and assistance to the GIS databases. And let's say if someone is driving a car and he stops somewhere, okay, then if he want to send back his location information to someone else, if he wanted to meet someone, okay, so at other end, what are the information which he should convey? So the information could be in terms of currently where that car is stopped. Okay. He need to share that information. Then further he need to share the detail about his car. Okay. So if he will send back his information to the other person who want to meet, then simply what that person can do, he can just put that location information in his tracking application, in the navigation application. Okay, so that GPS assisted navigation application will guide him the route. Okay, once he will be there, on the basis of given details of the car, that person can identify him. Okay, and obviously we also use nowadays very frequently the GPS assisted navigation system, and this is used. Okay. So the geo information which we need to collect for this, like the location information in a particular coordinate system, okay, that should be calculated by the GPS. Okay, then further detail of the object. Okay. Now let's say in this case there is an involvement of a person, there is an involvement of human. Okay. If the same thing we want to do by machine, let's say if there are two robots and one robot is driving the car and he stopped somewhere, okay, and he want to communicate with another robot, okay, and they want to meet, then in that case what should be done? See, our brain, so one common information that is shared, the first robot send the location information of the car to the second robot with whom he want to meet. Okay, that second robot can use the navigation device, navigation tool, and he can be there. But let's say if the navigation tool that is used, that has very poor accuracy, let's say its accuracy is 20 meter. Okay, so in that 20 meter, let's say there are many cars are there. How the second robot can identify that at which car he needs to approach? So in that case, the first robot should also send either the images or some geometrical detail of his car. See, being as a we are trained to identify. We are there out of many cars we can identify, but how the robot can process? So on the second robot, first that robot will collect the image or that scan the area. Okay, and further he will match the information shared by the first robot. Okay, and where the matching is optimal, that will be his destination. And this technique has been already used. Okay, like how the robotic different robots coordinate, they communicate with each other. So each robot is equipped with all the sensing devices. They are equipped with the photogrammetric sensor. They are equipped with LiDAR sensor. They have the GPS device. Okay, so GPS device help him to locate where he want to go. Okay, and further the other imaging devices and sensing devices, they help for the identification of the various objects. So this is the overall discussion. What is what? How to identify the object? How the geo-information help you to identify the object? And what is where? From where that information is acquired? And what is when? One time information is also attached over there. Okay. So it's a kind of multivariable analysis in a GIS database. Now the second part of geo-information is after collecting the information, how you process, how you manage that. Okay. The geo-information management includes how to store the data, further how that data is retrieved for various objects information collection. Okay. Like in this, if you consider a particular area and in which we have rivers, let's say we have buildings, there are grass field, etc. Okay. So if you want to separate each object, like if you want to separate the building and you want to delineate the rivers flowing through that area, okay, you want to identify the grass fields, then you need to execute certain algorithms on that data set to retrieve these information separately. Okay. Now those information can be presented for further interpretation and analysis. Like in the second figure, you can see that that different colors are given to the different area pockets. Okay, so the distinct color represent a particular object over there. Okay. Just see over there that black color lines, they represent the road network. Okay, and maybe this brown color represent the river flowing through that area. Okay. Similarly, other objects, they can be presented by assigning a different color to them. Okay, and after that, manipulation, how you after the management, how to manipulate the information, and it is based on the and it can be done based on analyzing the information available in the data set. Okay, so if you have any queries, then let me know based on the discussion we have today.